Thank you. All right, folks, let's get going. It's 6:04. Gaurav, you're here. You're ready to go? Looks like Gaurav is, or may need a few seconds. Well, Gaurav is here as well. Awesome. Let's see, folks. So, to all the alumni, very warm welcome again. And those who are not alumni, but hopefully soon to become alumni, also very warm welcome. Those who are prospective students as well. Very quickly, let me go through what Interview Kickstart is in 30 seconds, and then we'll go into the fun parts as well. So we have summarized what Interview Kickstart is on the slides. We have been around for about 6 years. We have had a little more than 4,000 alumni. We've had more than 5,000 plus offers at some of the best coveted companies and teams on the planet. And it's very routine for us to get offers out of the program, which are north of 250K. Our highest offer has crossed 700K. That was recent. Obviously, relatively rare. But it exists. We are in very interesting times. If you put your mind to it, you can up level permanently in your life. The core of the program is that there is no way to game the system. That is our deeply held belief. The only way to actually become a part of a strong technical team is really to be a better engineer. Right? When you are a part of the strong technical team, that's exactly what you'll be looking for when somebody interviews for your team, right? There is pride and there is craftsmanship in your work. And how do we get there? How do we become a better engineer? That's what Interview Kickstart espouses. And we have people like Gaurav and other people who come from that side of the world, and they help you get better, right? In a multi-month program. Our experts. We also teach patterns in problem solving, right? So you don't have to do random ass problems from here and there and hope that something shows up. Right? You do it the right way, and it's a system. Right? Systems are far more important than goals. A system of study, right? To go through one thing after the other. Right? I would love to focus this session on microservices instead of Interview Kickstart. I'm sure some of you will have questions on it. Please do sign up for our upcoming webinars. We do 4 every week. I'm sure you'll find a slot that's convenient to you. We'll be very happy to answer any of your questions there. It's an interactive session. It's an interactive webinar, interactive workshop where Ryan or I, one of us, will take it and we'll help you answer all the questions there. Okay. You can also email start@Interview Kickstart, but the best would be to just attend the webinar. Okay. All right. With that, Gaurav, let's go to the next slide. And yes, this is the most fun part here. All right. Gaurav and I worked at Box together. Some of you know, I was very early at Box, and I was fortunate enough to see a lot of good people come in during my tenure. Gaurav stood out. Gaurav recently left Box as a director of engineering, and he joined Confluent. Those who don't know what Confluent is probably have never worked with Kafka, but those who even come from slight bit of a data world, I'm sure must know Kafka. Confluent and Kafka came out of LinkedIn, and one of the hottest startups today. And before Box, Gaurav had his own stints and also worked at Microsoft for a long time. Gaurav is also a really fun person to be with and an exceptional instructor. Really lucked out, folks. And without much ado, we are already at 6:09. Let's get going, Gaurav. Over to you, sir.
All right. Well, thanks, Faang. That's a pretty high bar to maintain. I think you've sold me a little too high. All right. So welcome, everyone. Today's session, as you guys know, it's a MicroClass, and this is all about microservice infrastructure and architecture. Again, I'm Gaurav. Feel free to join me on Medium or LinkedIn. Just definitely send me a note that this is from MicroClass or IK. That way I know the context behind it. Yeah, so I already mentioned it, but what more specifically is right now, I am heading a bunch of teams that help with Confluent's foundation side of the world on the cloud, as well as some of the world on the observability. Similarly, at Box, I was heading the Microservice infrastructure. So as you can see, I know a little bit about it and happy to talk about it with you guys today. So let's jump in. Today we're going to talk about 4 major areas of topics: Microservice infrastructure, Microservice architecture, which is slightly different, although these are buzzwords that can be used interchangeably. I try to differentiate a little bit about it. We'll touch a little bit on monoliths and microservices, and then ultimately the lifecycle. And now, again, a lot of you had sent your questions, so the team and we kind of have tried to get them together, distill it, and these are the top topics or top areas that people have liked. So just to give you a little bit more detail, within these topics, we'll be talking about these things. So my intent with this microclass is to make sure, obviously in 1 hour, we're not going to cover like everything. It's a vast topic, but I want to cover some things in detail. That way you guys feel good enough as a food for thought to then further go and research. So this is not going to be an all-inclusive, all-conclusive, but this is more about how do you get started, what's the overall skeletal of where you begin. These are some of the topics that we'll try to touch very quickly. The content might be slightly heavy, and I might move at a much faster pace so that we have time for Q&A at the end. Cool. So what that also means is don't watch Netflix on the other tab. Stay engaged, stay with me, and it'll be useful. Awesome. So let's touch first on monoliths and services. So there's like a lot of roar about this in the Valley in general. I have personally seen like 3 different monoliths. I'm still dealing with some of that. So the one question I would like to pose to the group here is, think about it, a very large, well-built building or small but well-designed individual houses. Where do you want to live? And the analogy pretty much is exactly what a monolith is and microservices are. Now, I want to debunk some of this misunderstanding that monoliths are bad, monoliths are evil. That's not true. A lot of companies actually prefer to stay in monolith, and their business model actually succeeds in monoliths. Facebook is a great example for some part. So I want to quickly touch this. Microservices is not a one-all solution. It's up and coming. It's the new rare. However, I just want to say that monoliths are not all bad. Remember, monoliths are very efficient because you can have all the code in one place. It ships out, and it's really good for CapEx. You need fewer servers. You don't have to worry about inter-service hops and communication. You can share the code very easily in monolith. Everything is available for you, correct? You don't have to go out of a network, on the network to fetch something. And just being together, you can actually make larger refactors, changes, all of that. But there are definite downsides, which means it's all democratic. Either everyone fails or everyone succeeds, and there's a lot of problems around code isolation, release isolation, how teams scale, so on and so forth. But I just want to make sure the advantages that you know of as well. On microservices world, it's great. Individual deployments, small components, each service can be owned by a different team, all sexy, all of that. But it does come with a cost. Just like the picture, you're going to build the road so that everyone has access to their houses. You're going to have individual plumbing and individual water supply, individual electricity management, all of that, which means microservices, although they help you accelerate certain areas of your code bases, they do come with a price. And I just want to make sure that you guys understand that. So it's pros and cons. There's no one winner to take home all. But that's kind of how microservices and monoliths differ from each other. Cool. So now we'll jump on to the next topic, which is about just the infrastructure, microservice infrastructure. And to do this, and there was like a lot of feedback from the audience that we want something practical. So I'll give you as practical as I can get. I'm going to explain one request flow on Box and walk you through how it works behind the covers. This is something that my team's built. So, I know a little bit about it, obviously. I was there since like project new 5, that kind of a world. So the scenario I'm going to talk about is if you go to Box and if you look at certain like person's profile, this is Aaron. Aaron's the CEO. What happens when you look at this profile? So my intent is I'll walk you through the entire architecture diagram with the request flow, and then we'll go piece by piece and visit them on a whiteboard later. So when you make a request through an API to go check on Levy's profile, the first thing you're going to do is your request is going to go get navigated through the world of internet, to various different places on the world, and go hit Box's data center. Once it hits the data center, that's where they hit the gateway. An API gateway is a pretty much edge service that takes in requests over the internet. Once you get it, there's an option where you can actually go divert that traffic straight to an older monolith, and there's a monolith and DB and all of that, or your first interchange is with an identity ecosystem. Now, this is, we are touching the pieces of microservices infrastructure, and identity and security is a major component of microservices infrastructure. So your first handshake is going to be with your identity ecosystem. So what happens here is a request comes in, you go talk to identity, which means it's going to authenticate you. Authentication means login and password. Are you a valid user? But you might also get authorized. What that means is, are you allowed to perform this operation? And once that happens, you get back a JWT, Java Web Token, which means it's their identity for you. And that's now injected in your header. Once you do that, now the gateway's job is to go route you. Remember, the gateway is more of like a quarterback or an orchestrator. It takes in requests. There's a few sanity checks, authorization, authentication, maybe rate limiting, all of that. And then it says, go do the job, and someone else does the job. So you would either get navigated to something like an application service, which then talks to database or caches behind it, or you might talk to a monolith, which means it's a heterogeneous ecosystem, or you might even get navigated to another set of services. Now, the idea here that I want to convey is just to get your job done, just to load that home page, you might hit out like 5 or 6 or 10 different services in the backend. And then microservices infrastructure makes all of that seamless and easy. Ultimately, the infrastructure's job is to let developers focus just on the business logic so that they can do all of the heavy lifting. So you could be navigated here, or you can have cross-service communication, so on and so forth, or you can be talking to some of the infra services. Now, just to be clear, this is an actual diagram that I've also used in various different external tech talks that represents part of Box's infrastructure. So this is as practical as you can get into how systems work at scale. And we have scaled it to 70, 80,000 requests per second. So this is as real as it gets. And this is, and then we are going to touch some of these pieces. Obviously, a lot of these services get pushed to CI/CD pipelines. CI/CD is continuous integration, continuous deployment. We'll talk about how that works. We're also going to talk about how you log and monitor throughout your ecosystem. We're going to talk about service mesh a little bit. We touch on it. And we'll also talk about tracing. That's what you're going to get through this session. We're going to go into some details everywhere, but this is a very bird's eye view of what the end result would be. Now, very quickly, here is a set of technologies. Again, I just wanted to make sure people understand what happens in reality, our gateway being a very IO-heavy and less compute-heavy service has been built on Netty, which is a non-blocking architecture. Some of the services are in Java, some are in Node. OS is the API schema. You can see there's Scala, there is Java, there is PHP. Logging and monitoring happens through Wavefront and PagerDuty. Service mesh is SmartStack or Envoy. Lightstep is a tracing ecosystem, but there's MySQL, Redis, HBase, all of that. So again, this is just like a quick overview of what things are. Now let's go, as I mentioned to you before, and look into detail on each of these pieces. And for that, I'll go into more of like a whiteboard diagram here, blackboard in this case. So let's talk about auth N and auth Z. As I mentioned, when the request first comes in, your first interaction is with identity. Remember, no microservices infrastructure will work without a well-built identity ecosystem. So what happens when the request comes in is you hit your gateway, and a gateway in most cases is designed such that it has a bunch of filters. Now, filters are nothing but individual jobs that have been designed as a bunch of filters that are chained together. So you could have a request filter, or you could have a bunch of response filters. That's how gateways get designed. And typically what happens is one of your request filter is going to talk to your authentication service. It says, yes, this person is authenticated. Then it might go talk to an authorization service. And it's going to say, yeah, this person is authorized. Similarly, you might chain various different microservices in that request flow. One is going to go check if the rate limiter has been hit or not. You can read about what rate limiters do. Maybe another one is going to do some business logic that is very specific. So for example, if you're Uber, it might do like a driver health check before a request is accepted that, hey, has this driver, I don't know, paid his dues, or has her car well serviced, so on and so forth. So that's a chain of request filters, and each of this is a microservice hop. Similarly, you could have response filters, which means, by the way, make sure my data that goes out is secure. Make sure I have covered up everything so that I'm not leaking PII data or something like that. So that's how gateways, identity, rate limiting, all of that work. Now the fun here is, how do you then manage this whole inter-service communication? So let's talk about that a little bit. Remember, every service talking to another service is a network hop over the wire. This is where inter-service communication becomes difficult because there are lots of things to worry about. So now let's check what I mean by that. If I'm service A calling service B, what if the network fails? What if there's an error replied back? What if I'm not able to find B because B as a box or as a node, as a container is down? So there are lots of things that have to be taken care of when you deal with inter-service communication. Now the only golden rule that applies in microservices is that everything will fail. Literally, that's the only truth. Everything and anything will fail at any time. So every service, every code, every logic you build has to be built with that amount of resiliency in it. How you typically do that is every service usually uses an inter-service communication library. Now this is typical. You might have something else, but this is just what I'm calling as typical. You might have an inter-service communication library that takes care of all this logic, which means, hey, what if the service fails? Retry. What if I get an error? Go decorate that error with something. What if I'm not able to find this service? Go figure out something else. So that's how all of the inter-service communication is taken care of. However, there are certain other sets of problems. Think about service B. What if I'm getting too many requests, which I just cannot even sustain? What if my server is crashing because lots and lots of people are requesting the same thing? This is where concepts of throttling, this is where the concepts of circuit breaking, they come into picture. So what these libraries do is they prevent the incoming slaughter of requests by pushing back. So throttling, what it means is this service B is just going to respond with a specific header and a specific message that tells the client or the consumer or the caller to wait. Don't call back because I'm busy. So all of these intricacies have to be managed within your inter-service communication. This is what a lot of service meshes are doing these days. So again, I'm slowly touching on various different topics. As you might have realized, we're going to keep moving like this, and I'm going to talk about various different topics through a scenario. So what's a service mesh? A service mesh, as the name suggests, is a unified, well-defined networking or communication mesh that connects all of these services. Again, this is just a picture to describe. There are various different forms of service meshes. Some service meshes are centralized. What that means is all of your addressing, all of your navigation, all of your naming happens through a central server. Everyone contacts this central location to say, tell me how to reach somewhere else. Think about USPS or your regular post box. No matter who you want to send your letter to, it first hits your central post box. And from there on, the routing happens. So that's how a centralized service mesh works. But there is another category of service meshes which work, which are client side. What that means is instead of relying on a central source of truth, like a DNS on the internet. Each of these boxes will have their own copy of the network around them. So this is a client-side load balancer mechanism, which means if I, service A, want to talk to service C, I don't go talk to service C straight. I just send a request to my local host over here, and this has a routing table with it to know how to hit C. So that's like a service mesh that we can talk about within a client-side load balanced way. Cool. So, all right, so I'm touching various different topics that I promised in the slide before. All right, so now let's talk about actual services and the data that they fetch. So let's change colors to make it fun. All right, the biggest topic that people always deal with and ask me is, all right, you have this service, and I want to talk to my DB. Are there patterns? Are there ways to do it? Are there best practices? So on and so forth. Now, in a pure microservices-based architecture, textbook style, what they recommend is each service talk to its own DB only, or own table in this case, not DB per se. That's the norm, that's the gold standard. So what that means is each team that owns the logic can pretty much own the entire ecosystem of a service and a database behind it. Now, they can make localized decisions of, hey, I want to actually use Redis here. I don't actually want MySQL or DynamoDB or whatever, like 20 other DBs, right? They can also make decisions of, hey, by the way, I actually want to add a cache layer here because my service and the load I am dealing with is really heavy and I kind of just want to make a quick solution. So microservices architectures recommend that you approach it in this way. That way your teams are independent to make their own decisions, as well as you're optimizing for your own request flows and load. Now again, caching could be of various different types. You could have a read-through cache, which means before you read into DB, you always read through the cache, and then the cache figures out what to do with the DB, and so on and so forth. You could have a write aside cache, which means you never go talk to the cache, and there's so on and so forth. There's a ton of patterns around there. But the intent would be the caches I use to make sure reads are efficient. And going with this type of microservice architecture pattern makes sure that you can actually hit them in a sustainable way. But that's not where the fun is. Because in real life, what happens is you have multiple services talking to multiple different tables, or sometimes the exact same table. Again, if you have opportunities, if you're lucky and you're like dealing with a brand new system, then yeah, you might actually have one table and one service talking to each other. But in reality, that doesn't happen in many cases. I could be wrong, many cases. So what happens in reality is you have service A and you have service B talking to the exact same DB or table. And this is where the fun starts. Because look, read is easy. Read is that important. You go fetch the data. If it's not on the database, you go talk to a read-only slave, or you add some caching logic, so on and so forth, easy to solve. What about writes though? As you can imagine, there's a possibility of a race condition in writes, right? Service A might go update a certain field of a certain table of a certain row, which even B wants to go update. And suddenly you have a two-phase commit problem, you have a race condition, so on and so forth. In a distributed world, it's not as easy as, imagine you're writing, I don't know, SQL, Java code. You can just like transaction boundary, go do foo and bar, and then if not, transaction rollback. It's easy when you write it in code. But in a distributed systems world, transaction management is an extremely hard problem. Because you're not only dealing with rollbacks and all of that, you're also dealing with network failures. Imagine your service A who says go update some record, and you get a response, true or yes. But in reality, it never actually happened. And something happened with the network failed, sometimes happen like B doesn't get a response, so on and so forth. There's a lot of complication there. So distributed transaction has certain amount of patterns. Now, my recommendation would be to prevent distributed transactions as much as you can. Instead, add compensation logic, which means instead of relying on commit and then roll back, you say, let me go record whatever service it requires, and then if I don't find the data or if there's a race condition, I will go apply another logic that goes and compensates for it. So again, I'm touching on distributed transaction, definitely read up on it. There's a lot that gets here. There are a lot of protocols, there are a lot of best practices, so on and so forth. But that's typically what's going to happen with databases. Cool. Now let's touch on, so we can look at data access, transactions, quickly touch on sharding. Again, these are, by the way, all these are topics that people have asked for. So, that's what we're trying to cover. What is sharding? Sharding is a way to scale your DBs. Now, you can only store so much in your database because you're going to hit some limits, which means if you have a database and if you're hitting a limit, you can vertically scale it, which means you can add a beefier, bigger box with more RAM and more disk and blah, blah, blah. But that's going to only take you so far. Somewhere or another, you've got to split your data that we can store it in different places. That's what sharding is about. So sharding means if you have a long table like this with like millions and millions of records, you decide to divide that table into chunks. And then each individual table now resides on a different DB in different tables. Logically, it's the exact same entity. Logically, they all are a user's table, but physically, they're all stored in separate DBs. And then what happens, as you might imagine, is if I'm making a request and say, go fetch Gaurav. Now, the business logic or the service that's going to access this table has to figure out on which shard, which could be shard 1, shard 2, shard 3, shard 4, where does Gaurav's record actually exist? That's the logic that the service has to then figure out. They can figure it out based on another mapping table that basically just maybe alphabetically assigns me to a certain shard, or it could be deduced by the logic of like, let's SHA-1 or hash my name, and whatever key that comes up, we'll go store it in that shard. So sharding is a technique to go scale databases horizontally, that way the data can be split. Now, some as an exercise for the reader here is go look at various different sharding techniques, and you can find tons and tons of data. You'll hit something called as consistent hashing. Consistent hashing is nothing but the way to divide the data, that way the load balancing is easier. Cool. So what all did we touch from here? We touched on various different pieces of microservices infrastructure. Routing, how do you actually go to multiple different hubs? How do you do identity? How do you do inter-service communication? How do you do service meshes? We touched on auth and auth-z. Talk about data access, distributed transactions, sharding, throttling, so on and so forth. Now, remember, when you go build a microservices infrastructure in your company, and you saw the diagram I showed you before, all these pieces have to be built so that your engineers don't have to worry about it. And that was my intent behind showing you this diagram. That there is a lot here, almost every piece that I'm drawing here either has been pre-built as a service, has been built as a library. That way, every engineer who's working only focuses on the business logic of the service. Cool. So that's about microservice infrastructure. We are going to talk about logging, service tracing later on, but I just wanted to show you where we are. Let's move forward. Let's talk about this topic very quickly. Microservice or macroservice? Again, a very common question I get. So what I'll do is I'll actually talk about this, and I'll combine the whole how do you do microservice architecture question together. So remember, we saw microservice infrastructure, but what do you mean by microservice architecture? Architecture is a step back. typically what happens is, so I'll give you the analogy again. Remember the building diagram I showed? Imagine you're going from a big building into services. The then question happens is, who do you club together? Which apartments go stay together? Who does not stay with someone else? So if you have multiple families living in the building, you probably want to stay together in a single house, or maybe not actually, you want to avoid it. Depends on what the choice is. But in a keeping it more professional, think about the legal. Imagine there are like 4 different apartments shared by the legal team. You probably want all the legal team to be together. Imagine engineering or design. You want to make sure all of them sit together. But imagine there is like a extremely sensitive equity team that doesn't want to leak any data. You want to keep that team completely independent and put it in their own house. These decisions are what microservices architectures is all about. And that's where you decide whether you want a microservice or a macroservice. Because a lot of architectural design actually is driven from what your business is all about. Now, I'm sure you guys know this, that Uber went into like this extreme microservices world where they were known to have like thousands and thousands of microservices. That's just the way their business evolved. That's just the way decision they took. So they basically went to the complete granularity route of having individual, very, very thin microservices. Tons of advantages where, everyone's free and nimble, but it so happened that a team of 5 people would end up owning 7 services. Imagine the load, the operational heavy workload, inter-service communication, all those challenges. Whereas there have been many companies, I think Google famously had this somewhere out, where they went with very, very, I think Azure and Bing, they went with very fat macro services, which means the logical divide of your microservice architecture is very driven by what type of business you are in, what type of workloads you expect to happen, what type of user personas you want to highlight. Very different things. Because Bing Search wants to be extremely fast and they want to combine data from various different places, they decided that they'll club a lot of the logic into one big macro service that we don't pay the cost of inter-service hubs. Whereas maybe Uber, which is such an asynchronous work pattern for the business, because you're looking for an Uber and they're not like this, like looking for a car. It takes time. That's just the way the nature is, the marketplace. They could afford to have that asynchronous mechanism. So microservice architectures, and hence the micro versus macro debate, is very much driven by your business. It's very much driven by what entities your business has, and then how you decide to split your domains. So there is no one fix for all. You've got to do the research. You've got to figure it out. In my experience, in many places, it's kind of okay challenge engineering-wise to build a microservice infrastructure because, a lot of patterns, it's coding, it's fun. Microservice architectures is where companies fail because you either overdo it, you oversimplify it, so on and so forth. Just food for thought again, there is a difference between how you design your architecture versus how you just build an infrastructure to support your architecture. Cool. That's about that. Oops. Now let's switch gears. As I promised, we're going to touch on 2 more topics after this. We're going to touch on how you build a service, like a lifecycle, and I'm going to talk about operationalizing a little bit. So building a service and the lifecycle comes with a lot of frameworks. How we built it, and this is my example, but people might have different ways. We decided to make it very easy for developers. So I'm just going to show you like a quick diagram of how it was.
Gaurav, this is if you could not move back and just stay closer to the microphone, that might be slightly better.
Okay.
So because there's a bit of a noise and we lose you a little bit when you move on. So thank you.
No, sorry about that. It's hard to contain my excitement. I'm kidding. But let's look at this picture. What this tells you is what type of framework an engineer possibly can get. And this is like an example, real world example, again, practical example at box. But the idea is microservice has a ton of moving pieces and it's very efficient if you can templatize, frameworkize a lot of these pieces. So typically, you would want to start your microservices which are backed by APIs, which means you have an API repo. Now, REST, Open API Schema, read about them. These are very essential API design principles and tools. So typically you would start with an API. As an engineer, I would go and build my API design. I would feed it into some tooling that would take that API, which is either JSON or Avro or protobufs, you decide. And then you code gen a lot of pieces out of it. Because remember, APIs and schemas make it very easy to design your services. So typically from an API, you would build an SDK, which is your client side, your stubs, your data objects, your implementations, your interfaces, so on and so forth. And then the engineer will go and add those implementations. Similarly, we would code gen an entire service stack, which means there is a data access layer, there is like a implementation layer, there's a testing layer, so on. We would then give you out of the box lots of metrics and logs. Remember, each service, when it's running, it's going to have some typical same metrics and logs. And I'm going to talk about how those logs flow. But you want the access stats, which is when was my request coming in, when did it go out, what errors, what bugs, so on and so forth. Box is pretty big, and Confluent also is pretty big in Kubernetes and Docker. Everything in Confluent is Kube. So it could generate Kubernetes and Docker templates for you, generate code, generate access objects. Remember, when you have an API, you are already specifying what data you want to access. And you'll also get code-generated CI/CD template. I'll walk through that as an example later on, but Confluent has Semaphore, Box has Jenkins. There's so many different beautiful tools out there. But to add to it, what you want for coherence and consistency in your microservices is you want a good way to manage and operationalize your service. Once you're in, look, writing the code is just probably half the battle. I would actually say that's the easier battle, because you guys all are good developers. You guys know how to write code. Managing, operating, scaling your service is where the biggest challenge is. And if you look at the companies out here in the valley, everywhere, the companies who do that well actually are able to grow well. These are the companies who can scale elastically, have no downtime, all of that good stuff. Now, typical services should give you health check metrics. It should give you good traces, and I'll explain what tracing means, basic monitoring about your health, and a bunch of test results. So that's like a quick look into the lifecycle of building a service. Now, what I'll do is I'll quickly show you an example of a real-world Jenkins pipeline. This is like an example of a pipeline. So there are various different stages. If you're in an IDE, you save your code, you push in from GitHub. You're going to have your dev environment, your stage environment, your production environment, and ultimately going and shipping to production. We'll quickly touch on how production rollouts happen. That's the operational part. But this is like a real-world example of pipeline. Here are the different phases: design, development, testing, onboarding, and operationalize of your service. Your intent should be have very quick cycles, fast failures. So, for example, at the Box, people can ship at will, which means if I'm a developer, I write code, I deploy it to production, and it's gone. And I can know that test results are successful or failed as well. Okay, let's quickly touch on observability and operationalizing and hardware abstraction. So from the slide perspective, logging APIs, log tailors, tracing in the stack, health check alerts, dashboards, and we'll also talk about some form of resource isolation through Kubernetes and Docker. So let me quickly touch on the observability stack. I know we are probably running a little late, but it's fun. Here's a service. If I write some business logic, I typically, and this is running in a Docker container, I typically write to a certain mount file. So in my business logic, I'm saying whatever log4j or whoever your logging library, .log, and I'm saying it's an error, it's an info, it's a debug, so on and so forth. So I'm always writing to disk. Once I write to disk, typically I have a tailor or a daemon or a job or a sidecar, whatever you want to call it, that reads this log. Remember, this is a write-ahead log. I'm just reading this log and using a Kafka pipeline or something like that, all my services are shipping their logs into a centralized pipeline on various different topics. And now I have a larger system. You typically must have heard the ELK stack, Elastic Logstash Kibana. Now there's another job that goes and reads from this and does a bunch of number crunching, which means I'm taking all of the logs from an entire cluster. I'm doing indexing, I'm doing aggregates, I'm trying to combine them together, analyze them together, so on and so forth, which then ultimately are served to me via a nice little UI that I would know, okay, what happened at this moment on this machine? Or give me all errors that have been crunched by this system over here. That's how a typical observability stack works. Now, this is not just limited to logs, as you see here. This is not just logs, but you're talking logs, metrics, and traces. These are three essential components of an observability stack. Log, tell me what happened at this moment. Metrics, tell me what's the health right now. How was my CPU? How was the memory consumption? How are my incoming requests? Traces tell you where I have come from. So trace, think about trace as a needle that's sewing a thread across various different all the way back. I mean, in these days, COVID tracing is like a common word. Right? That's all traces is about. Who is the culprit and where did it come from? That's what tracing does. It can help you find out where this is coming from. So that's all about the observability stack. And there are traces, logs, and metrics. There's PagerDuty that is basically just a way to ping you, tell you what's going on. There are lots of other tools like Wavefront that helps you visualize. There is Datadog, again, that helps you visualize. All of this helps an engineer, support staff, customer success figure out what's exactly happening in the health of your system. One quick sec. All right. Final topic. The final topic is all about, I know you guys are interested in the hardware isolation. So let's look about Kubernetes and Docker. So what's Docker? Docker is a container. Isolation code runs. But when you have tons of different containers running, Kubernetes, or K8 as it's commonly known, is a way to manage these containers. And when you have to manage, you got to figure out who's healthy, who's alive, who's not alive. How do I reach a certain container? How do I address one over the other? So typically when I showed you that pipeline where I'm saying I'll deploy the code to production, remember all of these containers have the exact same service running. It's just that they are in a cluster. So what happens when I deploy code, and what is also typically called as a hot reload, is that Kubernetes will take a new piece or new version or new image of the code, and then it will slowly start applying it to one box at a time, one container at a time. So if I say, make sure my rolling restarts happen, it's going to go push the code here and say one container is on version 2, the rest of the container is on version 1. Then it's going to do the next one, next one, the next one. Imagine something happens here and this one fails. It quickly goes and resets, roll back, roll back. So Kubernetes with Docker takes that entire burden of hardware isolation. How do you push code into production? How do you manage nodes coming up and down? How do you just go add new container boxes? All of that has been abstracted from an engineer or from a system. So all you have to do in a microservices infrastructure world, if you're using any form, it could be Dockers and like Docker containers and Kubernetes, it could be VMs, it could be some other hardware abstraction techniques you have. The intent and the idea is you want a centralized place to manage your containers, manage the images on a container, and manage the addressability and discovery of your containers when the request is coming from the out. So when a new request comes from the outside, it doesn't know which pod it's hitting. All it knows is, I'm going to talk to this abstract IP or abstract whip I got, and then Kubernetes or whatever addressing technique you have will take care of routing that service to a specific container. Cool. So that's a touch on Kubernetes, rolling listed scales, traces, PagerDuties. Very quickly, I'll just talk about testing. Again, you saw the pipeline I showed you about that some time ago. Testing has various different forms. Just search for quality pyramid. You have your unit tests. You have your component tests. You have your API and schema tests. And then you also have end-to-end tests. But in a microservices world, you got to do stuff like longevity tests, which make sure the service is running and keeps running, scale tests, performance tests, so on and so forth. Again, these are all artifacts of your ability to run services at scale. Cool. So I think we have been covering at a very fast pace, but hopefully you guys are got a good sense of all the topics we covered here. I was supposed to keep more than 10 minutes, but I have time. So if you guys have more questions, we can extend for 10 more minutes. Cool. Thank you.
Awesome, Gaurav. Thank you. Thank you very much. Folks, again, this is Soham. We just heard from Gaurav on the microservices. He went almost breadth first. We had collected questions before the session, and that is what influenced this. Obviously, it's a vast topic, and there is no way to do justice to this in an hour. People have written books and books on it. What we are going to do next is we are going to take some of your questions. If you have a technical question, please don't use the chat box. Please use the Q&A box, which is here. Scroll through the Q&A box. Very likely, somebody might have asked the same question you have had. Right? So I will, Gaurav, what I'll do is I'll read out the questions.
Sure.
And then feel free to answer them as well.
Sure.
Okay. Folks, again, scroll through the questions, upvote the questions you really want answered. Also, please avoid asking interview Kickstart related questions if you can. Please do attend the webinar that's coming up. There are several that we do every week. Ryan or I will be very happy to answer all your IK related questions there. Let's keep this very focused on microservices. Right? The topic is vast. Gaurav knows a lot more than I would probably ever know about the topic. So let's make use of that. Right? Scroll through the questions, upvote the ones that you feel like you would love to get answered. Okay, I'll give you another minute. We have Gaurav, like he said, he has a few more minutes past 7 Pacific as well, and we can continue to get answered. Okay.
Cool.
Folks, very likely, folks, we will not be able to get through these many questions either. The questions just increasing at a rapid rate. So please do scroll, see if your question has already been asked. Then please upvote it, and we'll typically generally start with the top most upvoted questions, and then we go down from there. Okay. It's 6:53. Let's take a few more seconds. I still see upvotes coming in, which is very good. Right. Folks, if your question does not get answered, please note that there's nothing personal against you. It never will be. Just a question of time and just a question of managing all the questions. Right. Okay. Also, Kickstart classes are certainly not this big, but and we have very good ways of getting all the questions answered when we're in the class. So try not to project this to the class, though we do go quite in depth in a number of technical topics. Yeah.
So we just do you have something? Any question that you think so we should go?
Let's do this. So the top most voted question is is actually from one of the alums. What's the best strategy you would advise on breaking a huge monolith into microservices? Is it a good idea to do microservices only for new use cases that are being encountered, or is it a better approach to divide the existing system into smaller services?
Yeah.
Which way to catch it?
Very good question. Let me just pretext this. I have my own experiences. Again, dividing your microservices or building and going is very, very business specific decision. It's bespoke to every company. It depends on talent you have, the appetite to go build infrastructure in a company, the pace at which a company is moving, how quickly is it growing, blah, 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 blah. My personal opinion would be the following, that you have a monolithic ecosystem and you want to build a microservices world. I would say first start by proving that you have built a sustainable, well-defined microservices infrastructure within the company. And typically to do that, and that's like one of the tech talks I had done, was I call it steel threading your architecture, which means go pick an MVP that is small enough that it's not company ending, but intense and complex enough that it's not just a Mickey Mouse project. And go build all of that entirely in a microservices ecosystem, which means take care of routing, take care of identity, take care of data access, take care of interservice, all of that. So typically I would say the approach that has worked for me is first, stop the bleeding, which means go build everything new in the microservices world. That way you get used to, you train your engineers, you build a culture. Even microservices is actually a cultural change from monolith. And once you have stopped the bleeding, then you have a little bit of extra time to figure out, okay, now that my monolith is here, let me now design my strategy to slice and dice it into the ways I feel are appropriate for my company. So that's my approach. First is stop the bleeding and then slowly carve out pieces out of the monolith. Now, just a quick disclaimer before we go to the next question. Maybe your monolith might never completely die. And it's okay. Heterogeneous and polyglot architectures are reality, and it might just be okay. It's completely fine. Hopefully that's answered.
Very, very good point. Very good point, Gaurav. Hopeful, it's like, don't hate your monolith. The monolith has some really, really good advantages which microservices will never provide. Very good. Excellent. Awesome. The next question, can you provide some pointers or links or book suggestions that would help learning microservices better? And do you have anything to mind?
Sure. I mean, I think, look, okay, read the Google SRE book. I think it's really good book. It's a very like SRE focused, but that's the reality. DevOps is the world where we are all reaching. So learn to embrace that side of the world. Also read up on a lot of tech blogs that people have. We are fortunate, like the big boys of the valley, the Netflixes, the Googles, the Facebooks, always publish a lot of the stuff that they've done. I spent a lot of many years in the past reading about it. When I was assigned to build microservices infrastructure at Box, I went and spoke and interviewed many people at Netflix and Google and Uber and all these, because it's best to learn from them. We're not reinventing anything here. Let's be fair. I mean, yeah. So read up on tech blogs, read up on these books, and talk to people. Honestly, go find people if you know of in your network, in your friends, and see what their experiences have been.
Wonderful. Folks, I would like to add that Google SRE book is free and online for everybody to read. Tech blogs, I have personally found Nginx blog quite useful as well. I have also found, I think, Uber's as well quite useful, just for my personal reading. Especially microservices here, and Amazon also sells a book by author, forget Sam or someone, Building Microservices, also very good book, just for those who are more used to books versus articles. That could also. So design and data intensive applications, yes, that is also a very, very good book as well. Okay. All right. So that. What is the tool used by Gaurav for whiteboarding? It is pretty good, or blackboarding, I must say.
Hey, sorry guys, for that you got to sign up for the premium. No, it's funny. This is Apple Notes. That's all.
Look at that.
It's Notes. It syncs to my laptop and all of that.
Excellent, folks. There are other tools as well. Those who aren't on Apple devices, there is one called Explain Everything, which we use at IK as well, and it's actually very good. We have also written a blog post on how to handle remote interviews, and we have enlisted enumerated a number of tools in there also. So feel free to check out our blogs as well, and you'll see it there too. Okay, awesome. Thank you, Gaurav. Do you have any small project ideas for someone to get hands-on experience with microservices? If they currently don't work in them, right? Where do you get started and like do a small project? Any ideas?
Yeah, that's actually a good idea. Look, I think you don't need to necessarily build everything from 0 to 1. I think it's more important to have a compounding effect by building on top of something that's already out there. And you learn a lot just by doing it. So feel free to pick up Git projects that people have built. Now you literally can do a Git search of various different open source projects. Try them out. Try out an open source project and just start contributing to it. You'll learn a lot just by doing that. Second, think about a real life situation that you have and go build it on AWS. I'll give an example. When we had a baby at home, I wanted to build like a simple bot to know how many times the baby has pooped or peed or whatever like that. Very simple, using an Amazon dash button to just say peep, poop, whatever. So pick a personal pet project that you have and go build it on any cloud providers. Go get free credit from AWS or Google or Azure. Just use their DB, just use their networking stack, just use their cache. Just use those systems. Just by using those systems, you'll build a lot of practical knowledge of how things work. And fortunately, you don't need like real users traffic. Just write a bot that sends traffic to your service if you think you want to think about scaling. And just try that out. There's a lot which is available for free. So try it out.
I think one thing that Gaurav mentioned, which I think I would love to emphasize, is that use AWS. Use AWS. There are lots of stuff that is already on it, right? And you can make use of it, and you won't spend time in just creating the infrastructure. And you'll spend time in actually the request flows, which help you understand things. Excellent, Gaurav. Excellent as always. Example of compensation logic.
Sure. So what's compensation logic? Compensation logic helps you, so it's more of a fix forward instead of a rollback. Think about it like that. So imagine if we have a financial application where because of various race conditions or like various different things, you charged or you debited or credited your user twice. Why? Because debiting and crediting is not an idempotent service. So here's an example. Here's my app that's talking to my service, and I'm saying, please subtract, which is I've paid for something. But imagine the network went off. You drove through a tunnel. Something happened and the request reached the servers. It went and made that DB transaction, but then you didn't get a response because you couldn't get back that ACK acknowledgement back. So you press that again. And that means you've now sent two different requests to the same thing. Now, because this particular distributed cluster of services are stateless and it hit a different pod at the exact same time, imagine you got credited twice. Now, instead of building this complicated, let me do two-phase commit safety net and all of that, you could, or a company could, just write another simple bot or a tool that makes sure that there is an auditing in place, that makes sure it looks at the DB, makes sure it looks at unique transaction IDs, and ensures that, hey, maybe this something seems wrong here. The same user at the same particular time for the same have two different debits applied to it. So what you would do in this particular case is you typically would just send a message to, let's say, a Kafka message broker, Confluent Kafka, good plug there. And you would basically say, for this transaction ID, for this particular operation that happened at this time, go do compensation logic, which means go, instead of subtracting, add the exact same amount. And then asynchronously, another machine would go pick it up and make that change in a database. So especially in financial operations and services, sometimes you might see that your bank shows a credit processing. It's still in a processing mode because some of the bookkeeping and auditing has not been finalized. That's why you might see the money come to your bank or account, but you're not able to withdraw it or use it. because the compensation logic in place needs to still make sure that all the I's are dotted and T's are dashed. That's an example.
Awesome. Awesome. Thank you, Chris, for asking that question. Very good. And everybody else for reporting it as well. So that makes life much easier, helps us understand what everybody's looking for. How is a service mesh different from API gateway?
Very good question. Service mesh is kind of like a pretty modern, kind of a recent phenomenon, let's say 5 years, 8 years, 10 years. The purists might say they always existed, whatever. So there is an eventuality where service meshes might actually go replace your old school API gateways. So today, API gateway is more of an edge service that goes and does a bunch of routing. Whereas service meshes are an ecosystem that goes span your entire service network. So service meshes might like almost connect each of your node in an n-squared kind of a fashion. So gateways and service meshes, actually service mesh can do the job that the gateway has been doing, because service mesh is like read up, check out on Y, and read up on data plane and control plane as two different things. You'll have fun reading about it. So data planes and control planes these days actually do a lot of stuff that gateways can do. Rate limiting, throttling, circuit breaking, authorization. So there is an eventual world where maybe traditional gateways might not be useful anymore, but I think they're still like around, because gateways can provide a certain amount of value, which is ease of configurability, ease of adding new filters, as I mentioned in the diagram before, up here somewhere. Anyway, you guys know what I mean. So yeah, that's where they're both kind of coming together. Good question.
Very good. Very good. Thanks, Mehul. Is a rate limiter similar to circuit breaker and resiliency?
No. Short answer is no. Rate limiter is a component that helps limit the rate at which your requests are going. It's extremely, a well-built RL system is extremely configurable. But to give out like a pattern, and that is gross simplification, rate limiting is nothing but having a distributed counter. And circuit breaking is more of prevention. You could use a rate limiter to circuit break a certain request call, but they're not exactly the same. And if you skew and squint at it, each and everything that I spoke about can help with resiliency. So I can't like pinpoint and say, these help with resiliency. Everything we've done helps with resiliency.
Awesome. Very, very, very good fine point, Gaurav. Circuit breaker just breaks it. It doesn't sort of just limit the rate. So very good. Awesome. How prevalent is the sagas pattern, especially at top companies?
I don't know about. I don't know what companies in general, but yeah, sagas, distributed orchestrations, some form of compensations. These are all good patterns that are becoming more and more relevant and useful, because I think so far sagas were very theoretical, but now the tools have come. So managing distributed workflows, managing orchestrations, managing inter-service, all of that at a business logic level has been used or delivered through saga patterns. So I'm pretty sure it's relevant, although I can't say for sure, because I know Uber has it for sure. Uber has this new open source project called Cadence. So yeah.
And I'm guessing, Gaurav, that most of these places don't implement in a purist way any of these sort of methods and such. They're just the way nobody does agile in the exact same way, the way agile is supposed to be and such. So nobody would. And also the patterns have been usually formed because they just follow the business logic. Right? So.
Yeah. It's a pattern. People implement in different ways.
Makes sense. Thank you. Okay, and this is frequent in different ways that's been asked. Do you really need to have a different database for each microservice? What if we are managing a lifecycle and building multiple microservices to handle every stage of the lifecycle? Is there microservice? If these microservices don't share the DB, then we will need to pass a lot of data from one to the other.
Yeah, short answer, no. I mean, no one forces, no one asks. It's just, as I said, it's a recommended way. Now, let's, instead of thinking about whether it should be used or not, think about why it is recommended and see if that problem is what you're facing with. It's recommended for code isolation. It's recommended so that a team doesn't have to manage or be dependent on someone else's DB. It's recommended so that you can have the complete control of how your schemas evolve, how your caches evolve, so on and so forth. You don't have to do it. But instead, you then have to take care of a bunch of the scenarios I explained about how do you do updates. Where two different services are coming and updating the same DB. How do you control one place locking the DB, another place wanting it? And for typical like lifecycle management, I mean, you need transient data to be managed because lifecycles and workflows basically means you're constantly changing it. Maybe you don't use a persistent DB. Maybe you just use message brokers and Kafka, something like that.
And so doesn't that necessarily result in just more bugs because you're just passing a lot of data around and such, like consistency?
So it really depends. Everything you do can result in bugs. So it's all about the how. And in this case, my how, if you're very schema driven, if your interfaces are well defined, if you have strong isolation and interfaces on this is request here and here's the behavior I expect, then I think you can reduce the possibility of the bugs because there's a clean handoff between different components. The best way to think about it is think about Linux piping. You can run one command, have a pipe, run another command, have a pipe, run another command, have a pipe. Each of this command is well built, isolated, well tested. And all it does is talk to each other with a simple text file. So as long as that isolation is well done, well defined, well tested, well guarded, the number of bugs can reduce.
I see. So, and I suppose I haven't seen this one very directly, but I'm sure this follows this one. Is like, you don't mean to convert every SQL query into a microservice, right? In that sense.
Yeah. I mean, there is obviously like a function as a service and all of that like techniques. Somewhere I feel it's a little bit of an overkill. What I mean to say is, if you have a certain entity, which is everything about a user, limit that to just a user service. Everything about payments, just make sure it's all done in a payment service.
That will also contain the data sprawl. Right?
Exactly.
Awesome. Parikshit, hope that was useful. Is service discovery a part of service mesh?
Yeah. So again, service meshes, they help you connect your ecosystem together. You could use the same service mesh to do discovery. Now there are various different tools to manage it. Again, read up on Envoy if you feel like it's a pretty good tool coming up these days. It does use XCD to do some of the state management. Some people use Zookeeper, so on and so forth. So yeah, that's one of the jobs.
Yeah, Box, we tried Zookeeper, I remember. Funnily named, of course. In an interview, when somebody asks, do you use microservices? Is the expectation to be familiar with patterns like sagas and 12-factor necessarily or not necessarily?
Look, this is a very philosophical question, in my opinion. In my opinion, interviewing should be more about what can you answer based on first principles and not about how much knowledge or reading you've done. Which means even if you have not built microservices, the interview should be thinking about what would you do if you have to. And then think on your feet and see if you have the first principles in place. So yeah, I'm opinionated when it comes to interviewing, so I don't think I have a fair answer here.
Yes, but like I suppose you personally don't expect somebody to be familiar with these patterns the way they are laid out and such. If you ever ask a question like that,
unless I'm hiring someone at a pretty senior level in their job, and the expectation is to come and do it. But if I'm hiring someone for a slightly younger level where we expect you to come and learn, then I don't think it's a fair question to ask. So it really depends on what level and what type of job you hire interviewing for.
And if your resume drifts microservices and you've never heard of sagas or 12 factor, that's a problem, right? Otherwise,
everything on a resume is fair game.
yes, okay, but otherwise it's generally okay. Okay, awesome, good question, Sharad. When one container gets upgraded with a new feature and the other is still on an old build, how is it ensured that the end-to-end user experience is not inconsistent? The age-old question. I think microservices are not. Folks, this is the benefit of working in large spaces. Like to someone, this might seem like a very basic question. Coming from there, you would feel like it is actually a basic question. But anyway, sorry, I can go on and on about working at good companies and good teams, and these are some of the daily. Very good. Thanks. Please go ahead.
No, again, the intent is if you want to build services that are stateless, you want to build services that are stateless. That way, your HA, high availability and scalability are well done. This is where backwards compatibility is very important. And if you're not able to do backwards compatibility and if you're having a breaking change, it's okay. What that basically means is 1 of your million users, again, I hope this only matters when there's actually scale at play, 1 of your million users probably is going to have a request being dropped or not served. But again, if you look at it from a very different perspective, if your SLOs are about 99.9, 1 in like 40,000 requests or 5 in the 40,000 requests are not going to change it so much. So yes, there is an eventuality where you might have a drift in what your responses would be, but then the idea is to reduce that window as much as possible. But I do want to start by saying backwards compatibility is the most important thing. So don't have breaking changes, otherwise you have to deploy it at 2 a.m. where there's no traffic.
Makes sense. Thank you. In what cases are microservices architecture pattern not a good fit?
Yeah, I think again, as I mentioned, microservices come with complexities of all the stuff I spoke about. Sometimes you might really not have that kind of a business case. You might really not have those many engineers. You might not have that much traffic. Your business might be offline. All of those things.
Yep. And that might mean that you might even consider a monolith. Like if the business is small, the number of engineers is small, and the traffic is not that much, like you might consider monolith. Okay, very good, Gaurav. Very, very precise. This is a very generic question. Let me know if you would like to skip it. What are some of the challenges in scaling microservices? Do you have like top 2 or 3 principles in there that come to mind in scaling?
Yeah, I would say the operationalization of a microservices world is not easy. So again, you can write bad code and you might deal with a ton of like bugs and restarts and garbage collection being stuck. So there's a lot to unfold here, but I would just say operationalizing a microservice has to be thought of as first-class citizen, because that's where the biggest challenge is going to come from. It's hard. Scaling is like, I don't know, it's like an open topic.
Yeah. That's right. It's a vast topic as well. Okay. Well, thanks, Robert. What are some best ways practices to solve tracing problems and dealing with thousands of services?
Well, tracing is supposed to be the solve of problems, so I don't know what is a tracing problem. So if there's a problem with the tool, I don't know what to tell, but tracing will help you understand where things broke. So if you have like 5 different hops of your request being flowing, traces will help you get that lens to see, okay, this worked well, this worked well, this worked well, this worked well, oh, this is where it failed. So tracing as its own ecosystem comes with lots of spans and trace IDs and all of that. I would say sticking to the tracing protocol is very important. So read up on open tracing if you may, because what this does is it gives you like a certain protocol that you should follow. That way your visualization, your debugging and diagnosing is very easy.
Okay, very well. Thank you. As services evolve, new features are added, improvements, etc. are made. How do you gauge when to split and into smaller ones, and how do you divide them functionally, operationally? What's your thought process?
Yeah, I honestly would always divide services functionally, and I would make sure that we invest in right tooling and technology to manage the operational side of the work. Just because a service has high operational load, that's not the only reason to split it. I would say that think from a consumer's perspective and think about what workflows are contributing to the extra load or heaviness. It might so happen that a service is growing in code, but only 20% of the code base is actually being hit 90% of the time, 80% of the time. Focus on that, split that out. That way you can make localized scaling decisions for that 20% of the code. And then suddenly you realize the rest of the 80% is actually not very operationally heavy. I would always go with functional divide.
Awesome. Thank you for the crisp answer, Gaurav. API gateways reverse proxy?
Now, API gateways can act as reverse proxy, but that's not the tautology. No.
I see. Okay. What does OpenShift do?
What does OpenShift do? I'll have to Google that. I don't know.
Okay, very honest answer. That's actually very good. Thank you. Does Kubernetes also help enable service mesh?
Yeah, I don't think that's. I'm going to say something stupid, but I don't think that's the right question. Service mesh, it can exist with kube, with VM, with VMs, whatever. So it's kind of like orthogonal to each other. But yeah, Kubernetes definitely helps you with discovery, which augments your service mesh capabilities.
Let's see. These are less afforded questions. Can you touch base with WAF? Is that something that you know what it is, and would you like to touch on, Gaurav?
What's WAF? Someone can expand. I'm not really sure.
Let's move on. I think there are other questions as well. How do you establish inter-service communication, scaling service A, calling service B?
I think we touched that in the recording. So I think once you start reading the recording, look at it, you might be able to get through it again.
Very good.
All right, so we are at the end of the questions, I guess.
We are at the end of the questions. I think these are some of the things are you already covered, or they're sort of not necessarily microservices related only, like hold on, people are still upvoting questions. Is there a difference between service-oriented architecture and microservices architecture?
Service-oriented architecture, again, these are just terminologies. People use them interchangeably. As the name suggests, when this thing came out first, it was more of SOA, which is think service, don't think big. That's how service-driven architectures happen. Microservices happen as things started maturing. I'm sure in the purest form, there's like some difference in like how you address, how you discover, how you deploy. But for most practical reasons, people use it interchangeably.
Okay, awesome. 1 second, let me just scroll the rest of the questions. Are there any libraries you would recommend in building of this thing? Especially the specific question is, I recommend that helps polyglot microservice world for rate limiting retries and such. Gaurav, we can't hear you. So
okay, rate limiting. Check out Envoy's rate limiting. It's pretty good. I've used it. Confluent, like we're trying it right now. Retry logic, again, if you rely on service meshes, retries can happen. You can also just literally pick up any Java open source retry inter-service communication SDKs that will help you there. Also, you recommend sidecars for this, or libraries inside application code base? Good question. Sidecars are not cheap. They are extremely efficient for code isolation. You don't have to depend. There is no dependency BS with libraries and all of that. But sidecars also increase your capacity requirements. They need more memory, more disk space sometimes, so on and so forth. So it's actually a question about like capex, like amount of money you want to spend. And let's not forget, sidecars do mean that there's an extra network hop, although it's localhost. It's a little bit of complexity of managing. Sidecars can go down, so you have to have separate health checks for your sidecar, so on and so forth. So the question is between coding complexity and operational complexity.
Okay. Folks, I think, so I've been scrolling through questions. Many of these have been actually discussed by Gaurav session already. So I would urge you to go take a look at the recording once you post it on YouTube. Some of the questions are not related to microservices. They're just general system design questions as well. Some of the questions are a little far too philosophical as well, so I'm going to skip them as well. Looks like I think we are also coming to an end of this. There is maybe like one question. Gaurav, do you want to speak a little bit about Kafka, the role of Kafka in this at all?
Sure. No, actually, so
and Confluent as well.
Yeah, so there are two types of services in general in the world. There's one service which is online, which means a request comes in through HTTP or through like the world to you, and the second one is offline or async, which means you have accepted the request from the internet, you have done some processing, you have responded back to the user, and now your inter-service communication is not happening directly, but it's happening through a scalable, well-defined, highly available message buses. So Kafka is probably like the gold standard right now to decouple your inter-service communication to scale independently and globally. So Kafka and offline requests and offline services is probably where a lot of the future is going. So think about literally all your new apps, like the Lyfts and the Ubers and the Open Doors of the world, part of Box, part of so many Googles and Maps, they're all asynchronous. So Kafka is the gold standard when it comes to asynchronous message bus management. And obviously Confluent is a huge supporter and contributor to the Kafka project, but it also gives you an enterprise edition of Kafka, which is managed and hosted and all of that. I think event streaming, and so think about or look up event streaming. This, in my opinion, is the next wave of technology archetypes. Just like how databases were a wave, event streaming is probably like another wave coming up.
Wonderful. Thank you, Gaurav. Any last words about learning microservices or doing anything specific at work and such? What I personally think is about what you covered today. I think a college professor will not be able to cover it in 1,000 years, and just experience dripping in every sentence. Thank you very much. Any part would be very helpful, and thank you for extending this half an hour as well.
Yeah, one sec. I think I got stuck in my video somewhere, but yeah. Well, I don't have much to advise. Have fun. That's about it. Stay curious, I guess.
Fun with microservices and stay curious. Awesome. All right, man. Thank you very much, Gaurav, for your time today. And thanks all of you as well. Sorry we couldn't take all the questions. There are still 100 open questions. I highly appreciate everybody who's very curious about this. There is a real drive to learn. Please keep that up. Don't let anybody shoot you down like that. Again, nothing personal, just in interest of time. We have to just close the session. You want to learn more about IK, please go to the website, sign up for the upcoming session. We'll be happy to answer any and all questions there. Okay. All right. Thanks again, folks, and have a very good evening, whichever time zone you are in. Thanks, Gaurav, again for your time.
Bye.
Bye.